share your screen and just make it all is working well for you?
Yeah. Can you see my screen?
Super. Yes, it is.
Okay.
So over to you, Vijay. Thank you.
Yeah. So I think we have about 50 minutes left. I kind of took 10 minutes to introduce myself, but yeah.
But take your time. Don't rush. Right. Yeah. So don't rush. If we run over by 10, 15 minutes, that's fine too.
Right. So what I intend to do is I will keep my talk concise to about 30 to 35 minutes. And then I'll just, open up for Q&A. And what I learn is that primarily there are students who are part of the webinar. Is that right? Is that right?
That's understanding? Right. That's right. Yes.
Okay. And these are undergraduates or graduates or PhDs. I guess a mix.
Yes, there is a mix, but mostly undergrads in their final year that are going through the program here at Sabudh.
Got it. Understand. Okay. So my sole intent is to provide my experiences of applying AI to solve real world problems. And although I had given a different title to set up in terms of what I wanted to talk, but I have changed it a little bit to basically emphasize that AI today and for next 5 years is going to be an engineer's craft. I mean, there is a lot of noise around what AI can do and can't do. But if you really want to make an impact in practice, if you want to solve problems which can change the world, you need that engineer's craft. Is what my belief is. So I thought I will share my experiences in that regard as to why AI needs an engineer's craft, right? And I have already introduced myself. So I'm largely going to be talking about deep learning and computer vision. So AI is a broad term which is used in the industry, but I think since you have gone through your undergraduate studies, right? It's really about machine learning and how does the software learns through patterns, right? So it's the state of AI today is that it just has to learn from patterns. There is no reasoning. There is no logic that is there as a part of the AI systems of today. And hence, as I say, it is important to understand that engineer's craft. So what I will do is I will take you through my journey from 2012 when I joined IBM Research to today. I will also talk to you about the kind of brittleness that I have observed into AI systems, and I can also give you my perspectives on where the field is going over next 5 years, right? And if you want be it doing research, if you want to go for your master's or PhD, or be it joining startups or industry, what kind of things I feel would happen in next 5 years. So I'll just give you a mix of that as well. So that's basically the broad agenda that I have. And what I'm going to do is I'm going to take one example where all of us are going to solve one problem, right? Imagining that you are part of the industry, you are in a part of a company, and then let's say you have to solve a problem, right? So how do you go about solving that particular problem? And my focus during that is going to be how do you prepare data sets, how do you train AI models, and how do you deploy and maintain them? Because these days it is quite easy and fancy to say that, look, I will just download one open source data set, download an open source repository, and then train a model, and then I can say that I'm doing AI, right? But then it is perhaps 2% of the things that you would have to do when you join industry, or when you're doing research. So imagine that you are part of company like Flipkart, right? And I mean, as you know, Flipkart is is an e-commerce site, and it hosts a number of products. And let's say we are just talking about fashion as an example. I thought because there is a lot of young audience, I'll just take example of fashion. And the way as you know, the way Flipkart works is that there are a lot of sellers on the platform which are going to upload their inventory onto the Flipkart. Flipkart is a marketplace, and there are a lot of consumers who are going to come to Flipkart site and then do search, and then they are going to discover a number of products, right? Now the problem that happens in this whole process, I mean, uh, as I said, that vendors are going to upload their inventory to Flipkart, and then we as consumers are going to go and search and then buy the products. Problem is that the seller or vendor ecosystem is distributed, right? And if you imagine that there are 10,000 sellers across India who are selling fashion, the way they are going to upload this inventory, the way they are going to enter these attributes, what is the category of a particular item, what is the sleeve type or pattern type or neck type, it's all going to be different. But the basic thing that they're going to upload is an image, right? That, look, this is an image. I mean, either they will just take picture of that particular in fashion image. So here it's a sweatshirt, or I mean, they typically work with studios where they will get these kinds of pictures done, right? But then we as consumers, we are going to search through the search bar. We are going to type text, right? And if this taxonomy is not really uploaded, so somebody may call this particular fashion item as a sweatshirt, somebody may call it sweater, somebody may call it t-shirt, right? So if that taxonomy is not going, if if it is not well, then a lot of products are not going to get discovered, right? But then, given that we have these images, can we basically infer this taxonomy, these particular attributes automatically, right? I mean, that's basically the problem that we want to solve, right? And I will give you a glimpse of how this particular problem would be solved perhaps 5 years back. How you would solve it today, and if you have to solve it 5 years from now, what kind of things would happen, right? So that's basically the essence of my talk, right? I hope the problem is clear. If you have any questions around what is the business problem or what is the tech problem, we can discuss that. Feel free to ping me. I hope I will get some text message or I don't know, some kind of ping if it is not clear. But I'm assuming that the problem is clear to you. If it is not clear, please feel free to stop me anywhere in my talk, right? So let me just go ahead and then tell you um, how this particular problem would be solved 5 years back, right? So if you can go to Flipkart and then search in fashion category, there are almost 30 different kinds of categories, right? From t-shirts to shirts to sweatshirts, sweaters, jeans, pants, right? There are n number of things, and especially if you go to ethnic wear, there is kurta that is worn by men, that is kurta by women, right? So there are n number of things. So what you would do is, well, you would get all those images downloaded, and you would give them for annotation, right? So imagine you have a team of 20 people who are going to spend 4 days, and they're going to annotate each image with some particular tag or attributes, in that this is a shirt, this is a pant, right? And it would take anywhere between 4 days to 4 weeks, based on the data set. But then I'm just imagining that it would take 4 days, right? So imagine now you have these 30 classes. For each of them you have about 1,000 samples tagged, right? So you have totally 30,000 images tagged with you. And then you would download pre-trained model like ImageNet. You would use some kind of technique to classify the images, and it would take about 4 hours to train the model. So if you don't have access to a model like ImageNet, sometimes it may take 4 days, which is what I have here, where you will have to pre-train your model, right? So 4 days of tagging, 4 days of pre-training, and then you would train your model. to identify those 30 classes. So when I say pre-training, it is mainly unsupervised, where you could imagine something like a very simple autoencoder, which takes image as input and it generates image as output, and there is an embedding layer which is going to get trained, because you're saying that, hey, look, this is input image, I want you to compress it and then reconstruct the same image, right? So, and that compression layer, which we call as embedding, is the one that is going to get trained a lot, right? And then you can simply train classifier on the top, and then you would do evaluation. So I'm assuming that all of you are aware of what is a train set, what is a val set, what is a test set, right? So you would validate your model on val set, and then you would evaluate on the test set, right? And you will have the confusion matrix, where you can compute precision, recall, f1. And then if you feel that, well, my f1 is reasonably good, you will end up deploying your model behind an API, which can get an image as input, and it will generate the category of the image, right? The problem starts happening when you have to add new patterns. So let's say in the market, there is a new type of jacket that's there, right? And your classifier is now going to go from 30 to 31, right? What you have to do today? I mean, today you have to get 1,000 more images tagged for that new category of jackets, and then you have to retrain the entire model, right? I mean, because you have to get the 31 classifier, right? And then you do the same thing again, that tag data set, perhaps pre-train your model, train it, and evaluate. So if you see it, I mean, overall it has taken us perhaps almost 2 weeks to actually get to a stage where we have a model which is trained, and it might take another 2 weeks if we have to add a few new patterns as a part of this particular problem, right? And this is what people used to do, I would say 5 years back, or perhaps they do it now as well. But there are a lot of new techniques which have come up, and today if you want to solve this problem, my bet is that you can do it in just one day. So instead of waiting for 2 weeks uh, and going through the whole process of data set creation and training of the models, you could do it in a day, right? And here is a very simple way to do it today, right? So I'm not sure if you are exposed to concepts like self supervised learning. If not, I can explain that. So please feel free to ask me any question, because I don't really want any
Please
gaps.
do. Please do, Vijay, because they have not been exposed to it yet.
Got it. Okay. So okay, so let me just tell you the blocks that are there in this, one day pipeline, right? That there is just 4 hours of self, supervised learning. So imagine that you have the same 30,000 images, right? That, we had, got tagged, but now there are no tags with them, right? These are just, 30,000 images inside a folder, right? I mean, these are not really, labeled, right? Because the whole point is that it takes a week to get them labeled, right? So these are not really labeled. And we are going to learn a technique which I which I'm going to explain, but it would just take 4 hours, where this particular technique will take these 30,000 images, and you have a pre-trained model. What we do is this: for each of those 30 classes, we are going to get only 10 10 images tagged, right? So if it is a jacket, we are going to just get 10 different types of jackets tagged, saying that, look, these are the 10 images which is acting as a reference for this particular class, right? That's it. So overall, if you see 30 into 10, we are just going to get 300 images tagged. That's it, right? And it would take just 4 hours. So if you see here, it took us 4 days to get 30,000 images tagged. And again, by all means, it is underestimation. It would take a longer time, but I'm just giving it benefit of doubt, right? But here, as I said, we are just going to get those 300 images tagged, 10 images for each of the class, right? So totally we are up to 8 hours, and we are just going to index these 300 images. So what I mean by index is this: um, imagine three columns. First column is an index, really, 1 to 300, 1 2 3 4 5 300. Second column is actually embedding, right? Embedding of each of the images that we have in our 300 data set. And that embedding we are going to compute using this model that we have trained here as a part of the self supervised learning, right? And as I said, I'm going to explain that in a while. So I'm assuming that at least the students are aware of what is an embedding, if I'm not wrong. um, is that the right assumption? Hello, can you hear me?
Hello.
Yeah.
Sir, in this self-supervised learning, we have labeled data as well as the unlabeled data. Means there are some images which are tagged, and there are a few more images which are not tagged.
No, okay. So um, I would say this self supervised learning is more of a fancy term. There is, I mean, out of those 30,000 images that I mentioned, right? None of them are tagged. So all of them are unlabeled. As I said, these 30,000 images are inside a folder, and they are not really tagged. They are like one.jpg to 30,000.jpg. That's it, inside one folder. They are not really tagged, right? And I'm going to explain a technique by which we are going to train a deep learning model, which is going to give us very robust embeddings, right? So and that's what I asked. That are you? I mean, when I say an embedding, do you understand that, or should I explain that? So when I say embedding, it's basically a vector of 256 bits or float values, right? So is that something that you have learned as a part of your course, or not yet?
So not yet.
Plan.
I see. Okay. Okay. So what all things are covered as a part of the course? So is basically deep learning based classifier, is that covered as a part of the course?
Vijay, does get covered, but these students are primarily ones that have completed close to a month right now. So they are very much in kind of understanding, the basic linear regression, logistic regression, how those map onto conditional probabilities, understanding how to evaluate these and interpret the results. So it's a little early for them in the cycle.
Got it. Okay. So I would say then imagine that linear regression, right? That you have this sum over wixi. That's basically the equation. I hope that rings a bell, right? So that's wixi. So what happens if you have that xi as a pixel value, right? So you have image has let's say 800 into 600 pixels, right? So a lot of pixels. And let's say you also have 800 into 600 w's, right? And you do this wi into xi, right? So you would get a number, right? So now all I'm saying is that imagine instead of just one a number, there are two 56 numbers that are there. So you have one w, but imagine that you have two 56 w's, right? I mean, if If you have that, for every W that you have, you're going to get one number, right? So as I said, WIXI, you will get a number, but then if you have 256 W's, then you will get 256 values, right? Is this clear? I mean, if it is clear, then I'm good. If it is not clear, again I can explain that. But at least I want all of you to be clear until this point. Is this clear? How I am arriving at 256 values? If it is not clear to anybody, please feel free. I'll again explain.
So can you please repeat that?
So imagine you have an image, right? So you have an image, and that image has height of 800 and width of 600, right? So far so good. So you have and just imagine, so each of the pixel values that you have in the image, that value is going to be between 0 to 255. I mean, if you know about computer vision and image processing, you know that each pixel gets a value, right? And that is how you see the color of the image. So now imagine that that is 800 into 600, right? Is arranged in a row, right? I mean, it's a very long row, right? 800 into 600, right? It's a very long row, each pixel that's there on this row, right? So what would that be? 8 into 6 is 48.
480,000 approximately, right? 480000.
Correct. Yes. Yeah. So 480000, right? So these many values you have, just imagine them in a row, right? And now, since you have learned about a linear regression, you know about WIXI, right? So that's basically the equation that and we know that we over time we basically come up with W's, right? So the WI xi, so that we can start classifying some input x into two values, or we can actually start predicting some value. So now imagine W1 vector, which also has this 480000, these many values, right, on a row below the first row. And if you just do multiplication, right, and if you add them, if you do pairwise multiplication, and if you add them, you will get a single value. Are you with me so far?
Yes, sir.
Right now.
Yes, sir.
Right. So now imagine that this is not just one W1 that you have W2, W3, W4, right? And essentially just imagine them as random numbers that you have, right? I mean, just imagine them for now, that you have 480000 values, but there are 256 such rows that you have, right? So you have 256 W's, right? So far so good. And now basically each W you are applying to your original X, right? And you are doing pairwise, multiplication, and you do a sum. So for each of the W's, you are getting one value. And because we have 256 W's, you will get 256 values, right? And I'm just calling it as an embedding, or vector. That's it. So if you see, if I don't change my W's, and if I change X, because I'm going to change different images, right? I mean, I will have lots of images. So my W's are fixed. Those values are not changing. But if my image changes, of course, my X is going to change, right? And hence that 256 vector is going to be different for each of the images, right? I mean, if I have image 1, I will get one vector of 256 values. If I have image 2, which is different, I will get another vector of 256 values. And these two vectors are going to be different because the input image is going to be different. right? So far so good,
Yes, sir.
right? So now imagine that we are creating uh, an index, right? So when I say index, let's say out of our 30,000 images, we have chosen some, 300 images, right? And we kind of have, separated them into 30 different folders. Each folder contains 10 images, and each folder is for one, category, right? So be it sweatshirt or kurti or pants, right? So we have, different folders. In each folder we have, 10 images which belong to that particular category, right? So we kind of know images which belong to a particular category, and for each of those images I'm going to compute this particular, vector, right? So for one folder which has 10 images, I will get 10 vectors, right? And when I was, talking to you about that three column, right, that you have in the first column 1 to 300, second column you have that, vector, this is the vector that I talked about, right? And now with each vector, you also have its label, because we know that that particular image belongs to t-shirt or kurti, right? So we know that, well, this vector is for kurti, this vector is for t-shirt, and we only have an index of these 300 images, right? So that is the only annotation we have done, if you see so far. I mean, because we have, separated those 300 images into 30 folders, we had to do some kind of manual work to, separate them. So that I'm calling as annotation, right? Because some human has to sit through and then, separate these images, right? So that is the only work that I have done, right? And then perhaps I think it is too early to talk about the, kind of methods that I, wanted to talk to you about. But I will just explain you a simple way to do this, self-supervised learning, right? In a very simple way. Um, so um, so I think we have learned how to build that index, right? So I hope that's clear. But if you see, we have 30,000 minus 300, these many images which we still haven't labeled, right? I mean, nobody has gone through these images and nobody has really, labeled them, right? So how do we make use of them and then create a very robust embedding, right? And embedding extractor. I mean, that's basically the problem that self supervised learning solves. I'm not really sure that I have time, or whether it would be too early to talk about that particular thing. But essentially, what I'm saying here is that uh, um, there is a technique which will get all these unlabeled data, and then for each of those 30,000 minus 300 images, it will produce a vector. And it will so happen that the distance between two vectors which belong to the same image, that will be very low, right? I mean, I'm sure how to compute, distance between two, vectors. So, for example, very simply, if you have just two numbers, uh, 8 and 10, we know that in difference is 10 minus 8, 2. If you have two numbers, 8 and 100, difference is large. Now imagine a vector which has these kinds of, numbers. So we talked about this 56 vector, right? Where yeah, so imagine that there are 256 buckets, right? And each bucket you can place a number, 8, I don't know, 200, 13, like that, right? So you have these 256 numbers, and you have another vector. So let me just call it v1, and you have v2. So if you do pairwise subtraction, you will get another vector, right? But if you see the whole point is that we are trying to compress an image, right, which had 800 into 600 pixels into vector, right? And because the image could change in any way, this particular vector could also change. But this particular technique, self-supervised learning, it will ensure that if there is an image where a person is wearing jacket, right? And if you compute a vector for that image, and if there is an image where let's say you know uh, let's say the first image was of a man wearing a jacket, and the second image was of woman wearing the jacket but in a different color, right? So if you compute this embedding for both the images, right, they will be very close by. The difference between those two vectors will be small, because the model has learned that, look, although the person has changed, although the color of the jacket has changed, it is still a jacket, right? And hence this vector, these two vectors will be very close by. If you take that pairwise subtraction, it will be small, right? Versus if you have this image, and let's say if it has a t-shirt, right? And if you compute a vector v3 for that particular image, difference between v1 and v3, or v2 and v3, will be large, because this v3 vector belongs to a completely different kind of category, right? So that is basically what this particular technique will learn in a nutshell, that you supply it a lots of images, and it is learning behind the scenes that, well, I see the same pattern, and hence I should generate vectors, wherein if I see a jacket, I should generate set of vectors which fall close by. If I see a t-shirt, I should generate a vector which is away from the set of vectors of a jacket, right? So that is being learned in the background, if you see, right? And um, once the technique learns that model to produce vectors, right? All you need, as I said, is this 300 images which we have labeled, because if you see, we have those vectors for each of the images, right? We have 10 vectors for each of the categories, right? So we kind of know what is a reference vector for each of the category. So if you give a new unseen image, let's say a particular seller has uploaded an image of a jacket, right, which is new in the market, right? But it is still a jacket, right? So for that image, using our model, we will compute a vector, and we will just do search over these 300 vectors, because if you see, our model yet does not know whether there is a jacket or a t-shirt or kurti in that particular image, right? The whole point is that we want to auto tag that image with a new category, right? So there is an image that is new, we don't know what exists inside that. We compute this particular vector, and then with this vector we do a search over our 300 vectors that we have, right? And we are doing subtraction between two vectors, and then of course there will be a vector in our index where this difference will be very small. So that is an indication that, well, for this particular vector in our index, we know the label that this particular vector belongs to a jacket, right? So there is an indication that, well, since these two vectors match, in this image there must be a jacket, right? And let's say if we take top 10 vectors, where the difference is least, right? We have like 10 different labels, right? And if it so happens that 8 out of those 10 belong to jacket, that only tells us that, well, there is indeed a jacket inside the image, and hence we should tag that particular image with a jacket, right? If you have understood what I just described, I am betting that you have learned almost 30% of deep learning. so, uh,
So, Vijay, a question here.
yeah.
So, you're talking about using an autoencoder to create these vectors, right? And that's
Yeah.
inherently an unsupervised method. And then you're saying that based on the feedback you get, you're kind of doing maybe active learning then, right? You're actually identifying vectors that may have been mislabeled and labeling those also to aid future enhancement of that embedding. Would that be kind of a correct?
Yeah, so that's right. So basically, these new patterns is where we have to do a bit of active learning, because if let's say there is a new category in the market for which we don't have any vector in our index, right?
Yes.
Then
Yeah.
we need to add those vectors. So
Right.
that is where we have to understand that, well, if there is an image which contains a new category, and let's say if you do a search over our index, and if it so happens that, of course, you will get 10, if you see top 10 most matching vectors, but if you see that, well, difference is still large, right? I mean,
Yeah.
right, then
Right.
that, well, if none is matching, then it means that there is something new in this particular image. So then this particular image you can give to human annotators, who will look into it, and then perhaps discover that there is a new category inside this image, and
Right.
then you will have to add that image into our index, because that's something new. And then we also want to catch that when we see that particular product next time. So
Right.
that we have to add in our index.
So, I mean, with experience in applying, principal component analysis, which is in effect a similar idea, right? You kind of do an unsupervised reduction in dimensionality, and then you try to build a classifier. Sometimes that doesn't work very well, right? Because that reduction of dimensionality is blind to what you're really trying to achieve, as opposed to if you were trying to learn a CNN based architecture or a multi-layered perceptron, where the lower dimensional representation or embedding is learned with direction towards the classes, right? And so have you found that the autoencoder based approach may in some ways sometimes even obfuscate or hide that class boundary, right? Because it's not trying to learn the embedding to separate out classes as such. Do you find that also, or
Yeah.
not really?
So I mean, I would say you know uh, you are right in the sense when you said that autoencoder is more of unsupervised learning. I mean, there are new ways in which you could do self supervised learning. So but in general, these are techniques where you are working on unlabeled data.
Right.
Now um, now the thing is, of course, if you see, you are not uh, training these systems to do classification. If you see, right, I mean, you are just training them to perhaps reproduce the image, and in the process you are trying to compress the embeddings. So you know uh, uh, clearly it will work only if it is trained on a large number of images. So
Right.
PCA kind of techniques will hands down work better if, let's say, we don't have access to 30,000 images, we have access to only you know uh, 3,000 images, right? In which case, PCA would work better, because there is not just enough data for autoencoders to learn from them and then start discovering the patterns. So I mean, it, robust embedding extractors will get trained only if they are given a lot of data. If not, it is better to stick with techniques which are, traditional, which you mentioned, like PCA and, other kind of techniques.
Right. Okay. Thank you.
Yeah.
Anupriya, do you have a question?
Yes. So, Vijay, one question here. So, some of the items might, you would want them to appear under two or more than one category. For example, the image that we started with, you might want it to appear under, full sleeve T-shirt also and sweatshirt also. So, when we, I would say, get the vectors for those kind of images, where do you place them in terms of, clusters? I mean, under which clusters? And if a similar image comes up, then how do you determine under which category is it shown?
Yeah. So, I mean, okay. So, simple answer is that I was just taking example of deciphering the category. So, if you want to also decipher sleeve and pattern and neck, you may want to have different indexes, because the point is that with one model. So let's say if you want to train classifier, right, you would only have 30 classes for 30 categories, right? If you want to train if you want to identify sleeves, then you may want to train another classifier which may have 8 classes, which will have half sleeve, full sleeve, sleeveless, other kind of things. So to basically identify each of these attributes, you will need a separate model. So I was just taking an so I explained all of these attributes are a taxonomy as a part of the problem, but really we have been talking about just identifying category of a particular product. Did that make sense?
Slightly.
Okay. So I'll okay. So let's say instead of looking at 4 different attributes, let's say we only have to identify pattern, right? So in a category and pattern, these are the only 2 attributes that we want to identify of this particular fashion item, right? So if you want to train a very simple classifier, if you have to go that way, you will have to train 2 different classifiers. So imagine that you get this image as input. You have classifier 1 which is trained, which will basically classify this image into one of the 30 categories. So that's done. You will take the same image, you will have another classifier, and it will classify this image into 1 out of 8 different patterns. So all I'm saying is that there have to be 2 different systems to identify attributes for these 2 different labels. And that's the point I'm making, that if you have to go via the way of classification, right? So which also means if you have 30 classes in a classifier which is going to identify categories, right, you need to get data labeled for those 30 classes. If you have 8 classes in the pattern attribute, you will have to get data labeled that way, and then you have to train classifier 1 versus classifier 2 to be able to decipher these 2 patterns. The technique that I mentioned here, when we actually train using unsupervised or self-supervised way, we have to give images in appropriate fashion. So if we have to just talk about patterns, right, we cannot afford to give the entire image. Perhaps we may have to give a crop, crop of the item, so that we are only giving the pattern of the fashion item as input, so that when we do this indexing, that indexing is based only on pattern. Did that make sense? I mean, I talked about 2 things: how to solve this problem using traditional way of classification, where you have to train 2 different classifiers, and how to train this how to solve the same problem using unsupervised way, where you have to be a little smart in terms of how do you train the model in an unsupervised way. So in if you want to decipher, as I said, category, you can give the entire image. If you want to just talk about understanding the pattern, you may have to give crops in the image. because in the end your index is based on the kind of input that you want to process.
Okay, so thank you. Can I just ask one follow-up question on this?
Sure.
Yeah. So I understand that in various, category, whether it's sleeve or neck, we'll have different classifiers working. That I understood. Suppose under the category classifier, if there is an image which needs to be tagged under two categories, how is that handled technically? I mean, where do the vectors lie? If that bit can be clarified.
So see, what I talked about. So if I just take example of classification, right? For the sake of simplicity, right? So you have 30 different classes, and when you do a multi-class classifier, it means that you have input image and you're going to classify it into one among 30, right? There is also something called as multi-label classifier, which means when you give it an image, it can classify that image into one or more labels of the classes. So I'm not sure that things like these are covered, for example, cross entropy or softmax function, but basically you can play with these. And the way you train your model is either to basically predict one out of 30 different categories, or let's say one or more categories out of 30. So it's essentially, if you give an image to a deep network, either one bulb will go on, or there could be multiple bulbs which can go on, which basically signifies that this particular image may have more than one category. So I mean, as I said, there are different ways to train a classifier to be able to answer this particular question.
Yeah, that helps. Thank you very much.
So Vijay, please don't worry. The important thing for the students to get is, even if they pick up some terms, what we do is to kind of fill in the gaps, right? So please do carry on and deliver what you were planning to. And also, if you can provide some, material after the lecture,
sure.
We can add that into the, along with this video for the students to consume. So.
Okay. No, I think, I mean, it's actually my bad. Perhaps I should have asked you some more questions before.
No. I think this is great. So please carry on as you had planned, because
sure.
They will then get thrown into the deep end, and that's a nice way for us to then pull them in, right, and support them in their learning. So please do cover whatever you were wanting.
Got it. So then I'll just take 5 minutes more, and then I'll open up for more questions, because I would like to hear more from the students. So I think I'm assuming that at least you in general understood the aspects of classifier and other things, right? So as I said, training deep learning models, or for that matter any kind of AI model, is just a first step. When you have to put your systems into production, you will get exposed to things like web service, which means it's just an API where you can post an image and then you get a response. But sometimes to solve a problem, so for example, I just talked about this particular thing, right? That given an image, you not only want to understand category of that particular fashion item, but let's say also pattern, right? So imagine here that there is an arrow missing here, but imagine that you get you get a image here, and there are systems like Redis or Kafka, where you basically put this image in a queue, and that image is pulled by one one type of API, which is only going to identify category, right? So it will get that image, infer from that image the category, and because you also want to understand pattern, it will basically send that image along with the prediction to another queue, and then basically from that queue we will again pull that particular request and then do inference in terms of identifying pattern. So there are tools where you can deploy your AI models so that you can handle scale, you can handle automation, it's not like you have to babysit your APIs when you have to serve the request in production. So uh, I mean, if not anything, if you go back and then look into things like Kubernetes and other things, it will help you understand that there is a way, there is a systematic way in which you will have to deploy your AI models into production. And the reason I started with this topic of engineers craft, right? You as an AI engineer, I mean, your job is not just to train AI models, but also deploy them and make sure that they are actually running well in practice, right? So uh, for example, things like these, right? So what would happen if you have 30 different categories, and for, let's say, subcategories, you have data in abundance, right? I mean, if you go to Flipkart today, you will find like lots of products for t-shirts. But let's say if you want to find biker jackets, right? I mean, there will be lot less examples for those. So this in a particular problem is called as class imbalance, because if you want to train a classifier of 30 classes, and if some classes just don't have enough samples, the model may not be able to learn that particular class well, right? So you will come across challenges like these, where how do you make sure that your data set is in balance? Because if it is not, if you see one particular class is going to dominate the entire system, so there is a chance that you may give a jacket as input and it will still predict as a t-shirt, because it has only seen t-shirts, it has not seen a lot of jackets, right? So a lot of such challenges will be there when you have to go to put your AI models into production. As I said, just training on open source data sets, it's just 2% of the whole thing that you will have to do if you have to solve the problem end to end. Um, I'll just give you one example where where the industry is going. So, and there is this whole term of software 2.0, which means that if you want to solve a problem, you won't really write a software now. You will basically automate that by training an AI model. So if you remember, or if you have used Google search to translate between two languages. So let's say if you have to translate between Kannada and Hindi, right? So what Google had perhaps 5 years back was 500,000 lines of code, where it was very complex logic, a lot of innovations around NLP and other things, wherein if you give a sentence as input in, let's say, Kannada, it will uh, you know translate into Hindi, right? But today, that whole system is replaced by just one AI model, right? Where the model is basically trained on lot of data, a lot of these input and output examples of Kannada sentence and you know uh, Hindi sentence, right? So there are a lot of such pairs on which a model is trained, such that if it is given a new sentence, it automatically generates a sentence in corresponding language, right? So the reason this is called as software 2.0, because 5 years from now, the way you would write a software is not just perhaps very large Python codes, but perhaps very small codes which will import a lot of AI models to be able to solve a particular problem, right? So that is where the industry is going. Uh, I think that is what I had to talk to you. Just on in a final note, what do AI systems do today, and what they can't do, right? So there is this book by Daniel Kahneman which talks about thinking fast and slow, and it basically says that we as humans, we have two types of systems in our brain. One which is very fast and intuitive. I mean, you kind of know For example, if you are driving and if there is a vehicle approaching, you kind of know that how to turn the wheel instantly, right? So that's basically fast and intuitive system that we have. But there's other system that we have where, let's say, if you want to go from point A to point B, right? How do you plan your journey? How do you plan your map, right? Those things are slow and you need a lot of analytical aspects there, right? So but today, if you see, most of the AI systems can do that system one kind of work, where essentially, if you want to identify a person from an image, you can do that. If you want to as I said, classify a sentence into whether it is abusive versus it is fair, you could do that, right? I mean, there are these simple tasks which are fast and intuitive, which are possible to be automated using AI today, because it's really about pattern matching today, right? I mean, a human has a specific silhouette, and hence you can identify a human from any image. But as I said, right, so if you think about examples like how do you train AI models to play chess, right? These are huge models, and they are they required to be trained for over months. And even after that, if they get a very new move, right, on the chessboard, they basically fail, right? So that causal inference is a long way to go. So most of the AI systems, other none of the AI systems today have any kind of reasoning ability, right? But hopefully that will change over next 5 years. And the reason I said hopefully, that's because, of course, AI, when applied to solve the right problems, it is good, because as humans, it is going to help us to get rid of a lot of mundane tasks, so that we as humans, we can do a lot better with our time and other things, right? So I mean, there is also that aspect of how do you apply AI to solve the right problems. But I think we are getting there. So that is what I had to talk to you. Feel free to ask me any questions. I'm not sure that it really helped. I think I was on a different plane versus what the students were. But yeah, happy to answer any questions that you may have.
Not at all, Vijay. And, so thank you for that. There's a question here. Instead of training two different classifiers separately, can we use pre-trained parameters of first classifier to classify the second, only changing the output layer? So I guess he's kind of referring to
Perfect.
transfer learning there. Yeah.
Perfect. Yeah. I mean, I'm glad that you caught that. Yes, that is possible. That is the better way to do it. Yes.
Sir, one more question. Uh, um,
Yeah.
yes,
Please.
in tabular data, we are handling the class imbalance through the use of the sampling techniques. So, in the image data, how we can do this?
So, sorry, could you please repeat the question? I'm sorry.
So
Yeah.
Vijay, yeah. So Braj, let me try and paraphrase. So when we have a class imbalance
Yeah.
in non-image data,
Yeah.
the typical approaches to handling that are to undersample the larger class, or oversample,
Got it, yeah.
or create synthetic examples, right? Now, on the image side, Braj's question is, what would you do?
Yeah, yeah. So let me just show you one slide where basically there are a lot of things that you could do. Just a minute. Yeah. So there are, there are things like you could generate, synthetic images of the classes for which you don't have enough samples. In our company, we use a VR tool where we could just provide some sample images, and it will generate similar looking images the way they would look in real world as a part of the VR tool. So the best way today, at least in case of deep learning for computer vision, to get rid of class imbalance is to generate more data. Either using augmentations on existing images. I mean, you could perhaps apply augmentations like blur or sharpness or color contrast, or you could generate new images, or you could use some tools by which you could generate real looking images. Yeah.
So you mentioned VR out here. What does VR stand for? So
Yeah, sorry, I'm sorry. So it stands for virtual reality, which means I think you might have played video games, right? At least in my time, there used to be this game called Counter Strike. I don't know whether you have played that game, but essentially there are softwares like Unity, right? So I mean, just like you have Android Studio, there are other studios. One of them is Unity, where you could create VR apps. Now, what we do is this, right? So let's say if you want to, I mean, in a VR tool, you could actually load a real looking environment, right? Let's take example of a game, right? I mean, and if there is a game like, I don't know, Duck Hunt, right? And if you want to basically generate more ducks, right? So using programs, you can place lots of ducks as a part of the environment, which will help you to generate more images or more cases by which you can spot ducks as a part of the real world setting. So let's say if you don't have a lot of images for ducks, then you could do that.
okay.
Sir, I have a question.
Yeah.
Yes, Vipul.
Sir, like you said in
You can just call me Vijay.
Counter-Strike,
Yeah. Sorry,
you
go
said
ahead.
in Counter-Strike, there's a thing called backban
Okay.
to catch cheaters, but they are not they are unable to catch them. So they have enough data to catch the cheaters, so still they can't. What's the reason for that?
Yeah, good. I think there is one, Counter-Strike fan at least in the group. So I didn't really get the question, and it's been like 10 years since I've played the game, by the way, that I used to play a long time back. The example that I was, giving was this, right? So let's say, you want to train, people detection model, which will basically put a box around a person in an image, right? And let's say if you don't have a lot of images of real world, right? Since you have a game like Counter Strike, where you can find you know you know real looking humans as a part of the game, right? You can take frames out of your game, and those frames can basically act as your images. I mean, they can act as your
No, sir.
training set.
Sir, my question was like in Counter-Strike, people cheat like people do aim bots that it automatically shoot heads.
Okay.
So that's a cheating because that's not a skill.
Okay.
But we have enough data to counter that. But in Counter-Strike, it's not it's unable to do that. So what's the reason for that?
I think this is some new feature. I guess as I said, I haven't really played Counter Strike in last 10 years, but yeah, I was just giving example that you can generate new images by
Right.
making use of a VR tool. Yeah.
So another of the listeners here, Shivam, is saying, what about image data generators? You've got GANs here on here, and variational auto encoders, I guess, could also be used. But then also simple things like rotation and flipping to kind of handle that. So what's your experience with using those compared to GANs?
Yeah. So GANs overall today don't really work that well in practice, to be honest. And the kind of other augmentations that we talked about, flipping and rotation and other things, those work much better because that is controlled. That is still, I mean, you're applying that augmentation on an real image. So you are still getting a good variation. GANs, they, I mean, for very few problems, you will see GANs actually generating images which are real looking. But traditional techniques of applying augmentations on images still rule the game, I would say. Yeah.
Great, thank you. There is another question here, and I think this is a separate webinar, but could you please explain a little more about ML model deployment using Kubernetes, using Docker orchestration, and so on? But I think that's a longer conversation, so
yeah,
maybe we'll have to kind of save that for a separate one, Santosh. There's also a request from Sai Nikhilesh that he says, "Great session, sir. If possible, could you please share some resources such as GitHub repositories so that we could further get hands-on experience with autoencoders and how to handle imbalance classes?" So I don't know whether you have some handy that you could propose to the students.
Sure, I will share a few links.
Yeah, that'll be great. Thank you. Vijay, thank you so much. Yeah.
Sir, I'll ask one question, sir.
Yes, please do.
Sir, like in case you are saying that we are using self-supervised learning to label the classes, label the unlabeled images. So what happens in case that if we measure the distance between the two images and two different labeled images have the same, they somehow end up having the same label. So does that matter in real life, that the prediction that we make is wrong, or it doesn't matter?
No, of course.
I mean,
yes. I think that's a good question. Again, I'm glad that you could think about it, which means I think whatever I explained to some extent, I think it was fair. See, it could happen because in the end, when we are training an embedding extractor, we are training it on input data, and it's not like the input data is going to capture all possible variations in the world. So any kind of AI model will make mistakes, right, when you use them. Now, the way to infer that is as follows. Let's say if your AI model is doing predictions on 10,000 images. Typically, you would sample 500 images, and then also verify the actual prediction with humans to see that, look, I mean, nobody has any clue as to what kind of predictions the AI model is making, right, on these images. So let me sample these 500 images, and then see if the prediction is actually the ground truth or not, right? So, and if we find that where there is a lot of deviation in terms of ground truth and prediction, it means that the AI is not really trained well, and you may want to fine tune it. So mistakes will happen in real world. There is a different cost to mistakes. In some cases, recall matters a lot. For example, if I have to give example, let's say COVID test, right? So if you want to do COVID test, and if you are recall is low, which means a person has COVID, but you're not, I mean, you are saying that that person does not, right? It has a high cost, right? So it is okay if you say that a few people which perhaps don't have COVID have COVID, but that is definitely better than saying that this person does not have a COVID, but that person actually has a COVID, right? So I mean, as I said, the these kinds of inaccuracies will be there, and for different problems they will have different costs, right? And you have to be again mindful of the systems when you deploy them, because especially in a few sectors like healthcare and others, the cost of false positives and false negatives is high. Yeah.
Great, thank you, Vijay. And there is another question which is probably related more to the reference you had given, in the beginning as a use case of what the problem is that you're trying to solve. So Vijay is asking how to select the shelves for a particular product in a supermarket. So you talked about how visibility is an issue, but then at some point, a shopkeeper has to kind of make all products visible. Is there something that you're working on there to say, for certain products, this shelf is a better shelf than others, or is that a future kind of development that you would say to even optimally decide where to place products?
Yeah, so definitely products which are kept at eye level, those sell more. And the problem, really is that what do consumers actually want, and how do we place the most desired products at eye level? So that's always a game of, cat and mouse, because only through mining patterns you can identify that, well, consumers really want this particular product, and you have to place them at eye level shelf also. So it's again all based on evaluation of data, evaluation of consumer preferences, what really affects their preferences and all.
Right. Great. Vijay, thank you so much. This has been an excellent talk, and you can see from the volume of questions that all has not been lost in what you were delivering. So we do have a mix of students, and I really appreciate you exposing them to new technologies that they have not been exposed to yet, because then that gives the impetus for them to learn that space better. So thank you again, and we hope that this is a start of a long-term relationship where we'll be able to entice you back again and again to give a little more gyan to the students, and take out some time on a Saturday morning. So thank you again.
Thank you very much. Thank you for giving me this opportunity. Always pleasure to interact with students and then share whatever I have learned. Thank
Lovely.
you again. Yeah.
Lovely. Thanks.
Thank you. Thank you.
Take care. Bye-bye. See you.
All the best. Yeah. Thanks. Bye. Bye.